All right, guys, welcome to Friday. Today we're going to be talking about independent and dependent events. Um, Today we're going to learn the difference between them and how to find their probabilities. First thing I want to do is talk a little bit about yesterday. Yesterday we talked about this word and, all right? And we said that when we were going to use the word and, we were going to subtract out our double counted items because we were finding probabilities of events that could happen at the same time. Um, like finding the probability of drawing one card and have that card being a face card and a heart. So maybe the probability of a face and I'll just draw a heart. Um, because we could have face cards that are hearts, we had to subtract out double counted things. The reason that I wanted you to treat this as the word and is because most of your homework problems last night use the word and to describe this scenario. Um, and I want you to realize that we could have used or to describe the same type of scenario. Um, if I want to find the probability of a face card and a heart in one draw, or the face card or a heart in a single draw, I could have easily used the word or to describe the same scenarios. Both of these require subtracting or adding the probabilities together and then subtracting out the double counted cards because it was only one draw. From now on, I want you to think of these kind of problems as using the word or. So anything from yesterday, we're going to take those same problems and we're just going to make our keyword for those types of problems where we are going to be adding probabilities. We're going to use the word or to indicate what we're going to do there. Okay? So let's move on with today's stuff. Independent events. What are they? Independents or events are when the outcome of one event do not affect the results of any outcome of another event. They are two separate events, like drawing two cards from a deck instead of our one event from yesterday. So we get a little bit of different stuff going on here. Probabilities and independence of these things. The key word that we are going to use is the word and. All right. Um, when you look at an example, I can say that I draw one card from a deck, replace it, and draw another. Okay. Um, that is two separate events. Okay. And if I draw one card and I put it back, when I draw the second card, it doesn't matter what I got in the first card that I drew. Okay. The first card doesn't affect the second card because I put it back in the deck. Each time I draw from the deck, there are 52 cards because I've replaced it. Okay, that's going to be a key phrase, replacement or without replacement. All right, so let's look at an example with this. If I want to find the probability of getting a king and a heart, your problems in your book, by the way, will be written like this. It'll say, find the probability of a king, comma, and then a heart. This is what we do. I want to find the probability of getting a king on the first draw. All right, so there are 4 kings in the deck out of 52 cards. And I want to find the probability of, on my next draw, getting a heart. Well, if I put the card back, saying that maybe I drew the king of hearts, it's now back in the deck, that's going to be another 13 out of 52. Okay, so what do I do with these probabilities? Think about this. If I were to add these, that would mean that it would be getting easier to do my next drawing. Okay, but what I'm saying is that on your first card, you have to get a king, and then you put it back, and now your second card, you got to get something completely different. You got to get a heart. That's actually making it harder. So adding here is not what we're going to do. We're not going to add. What we are going to do is multiply these probabilities, okay? So what I'll end up getting is if I take 4 times 13, I get 52. And if I take 52 times 52, I get 2,730. 4. Okay, that works out to a probability of 1.9%. Okay, so when we do independent events, okay, I want you guys taking the probability of the first and the probability of the second and multiplying them together. Okay, if one event does not affect the other, that's what we do. So in general, when we look at this, if I say I want to find the probability of doing one thing and then the probability of doing the other, we multiply these probabilities together. Please stop the video at any time. I'm sorry I didn't mention this before, but please stop the video at any time and you will be able to write down the notes for this as I go through. Okay, so let's go through a couple of examples here. A lot of your problems in your homework are going to look like this. A marble bag contains 3 green marbles, 2 red, 4 yellow marbles, and 1 black marble. First thing you got to do is realize how you're taking the marbles from the bag. It says 2 marbles are taken, all right, and it's with replacement. That means after I've taken 1 marble from the bag, I put it back, and then I draw the second one, okay? That means that these are independent. Okay, independent events because of the replacement. Geez, I didn't spell this right. Independent. Okay. So here we go. I'm going to find the probability of getting a green marble. If I add these all up, I got 10 marbles total, so that's my denominator. And there are a total of 3 green marbles, so that goes my numerator. All right. Then I got to find the red. There are 2 red marbles, so I take 2. And because I've put it back, there's still 10 marbles in the bag. I multiply these things together. I get 6 out of 100, and that is 6%. Okay, let's look at the next example now. Same scenario, and now I want to find the probability of getting a green and then another green. Okay, so again, that's going to be 3 out of 10, and because I put that green marble back, it's going to be 3 out of 10 again. So this is going to be equal to 9 out of 100, or 9%. So I have a little bit better chance of getting 2 green marbles in a row than I do a green marble and then a red marble, because it makes sense. There's only 2 red versus the 3 green. Okay? All right. Moving on here. Dependent events. What are dependent events? Dependent events are when the outcome of the first one affects the outcome of any other event after that. All right. So the key word for this is still and, but we want to look for the phrase without replacement. That means you took something and you didn't put it back. And if you don't put it back, now you don't have that same thing to draw from the second time around, be it a bag of marbles or a deck of cards. So let's look at an example. This is the same example from before. 3 green, 2 red, 4 yellow, 1 black, okay? And now what we're going to do is we are going to take from the bag and we're going to keep them. We're going to not replace these. So let's do the same problem that we had before, but not replace them. So if I take my green marble the first time, I still have 3 out of 10. But now think of this. I've taken that green marble and I did not put it back. So that means now there are 9 marbles in the bag, and not only are there only 9 marbles in the bag, there are no longer 3 green marbles in the bag. There are now 2. So these are the probabilities that I multiply together. So now I get 3 times 2, which is 6, over 10 times 9, which is 90. Okay, 6 over 90 gives me 6.6% chance. Okay. So I hope that makes sense. Without replacement, in this particular example, I've kept a green marble, so there's 1 less, and there's 1 less in the total bag, so my numerator decreased as well. Let's look at another example here. So in general, in dependent events, the probability of A then B, and this sounds a little bit confusing, I still take my probabilities and I still multiply them together, but my second probability is altered to kind of adjust for what happened in A, like we did in the first example here. I adjusted my second probability because I've already done event A, okay? So probability B is adjusted after A already happens. Okay? So again, pause the video if you need to write those things down. So let's do some examples here. Let's go to deck of cards. I draw 2 cards from a deck, and I do not replace them. All right? I want to find the probability of getting a king and then a queen. All right? So here we go. The probability of getting a king on my first try is 4 out of 52. We know that from examples that we've done in the past. Okay? Now, I keep that king. Then I draw a queen. Well, because I kept a king, there are still 4 queens left in the deck. But because I kept a king, I kept a card, there are now 51 cards left in the deck. And now I multiply these together. I get 16 over 2,652. Okay? So that gives me a percent of 0.6. And that was my probability that I would give on a homework assignment. Okay? Let's look at the next example. I want to find the probability of getting 4 of a kind, 4 aces in a row. All right? So let's look at this. My probability of getting the first ace is still 4 out of 52. The second ace is now 3 out of 51. Second ace would be 2 out of 50. And the last one would be 1 out of 49. Multiplying this all together, 4 times 3 is 12, times 2 is 24, times 1 is 24. So I got 25 for a numerator, and my denominator is huge. It is 6,497,400. Okay? So the chances of you of getting 4 of a kind in a poker hand, and this is also a little bit modified because obviously you get 5 cards instead of 4 in poker, but I'm kind of losing track here. The probability of getting you a 4 of a kind in this type of poker hand is 0.0003%. Okay? That's a hard hand to get, and you can tell because that's your percentage. All right, so here is an extra credit question that I want you to do. Again, it's extra credit, but given the last couple tests, some people may want to do this. I want you to research the Powerball lottery and tell me whether the calculation of the probability is a dependent or independent calculation. I then want you to calculate it using a method that we discussed in class, okay? And then write me a little bit about how you did it, okay? So I want to see, I want to see you research the Powerball lottery, okay? And there's lots of websites for this. You can just Google it. Tell me that if you're looking at this, is this independent or dependent calculations, and then actually calculate the chances of you being filthy rich from winning the lottery. All right, so that's it. Your assignment is up on the board. You can find that right behind my desk where you always do, and I'll just leave you with this for Happy Friday. Take care.